Okay, let's say you're given a problem where you have to prove that angle A is congruent to angle C. You're given a triangle and you have some things that are given to you about the triangle, or the two triangles in this case. So if it's not written out for you, like drawn on your shape, you should probably write in whatever is given to you. So in this case, you are given angle BDA, so angle BDA, which would be this one right here. And we know that that's congruent to angle BDC, so BDC. And we know that these are congruent. So we're just going to put a line through it to symbolize that it's congruent. The other thing that we're given is that line BD is an angle bisector. So this would mean that the angle up here, it also applies to the one down here, but we're already given another proof for that. So if we know that the line BD is an angle bisector, it means that if this was one whole angle, this line splits it evenly in two, which proves that these two angles that it is now split into are congruent. So now that we have what's written out, we can say, okay, well, what else can we prove out of this? Because there's no proof, it's just angle. So the other thing that we can figure out from this, it's not explicitly given, it's not explicitly written out that this is going on, but we can inexplicitly determine it. So one thing we can see is that line BD is a shared side between these two triangles. So we can say that line BD is congruent to line DB. You can write BD is congruent to BD. It doesn't matter, it means the exact same thing. So now we can start making our flowchart. So we have our three big bubbles, and we have what we need to prove and the final thing we need to prove. And we're going to have one more bubble up here, and you'll see what that's for in a second. So we know that it's explicitly given to us that these two angles are congruent. So let's write that in first. Angle BDA, oopsies, is congruent to angle BDC. And that's given. The other thing that we have is this shared side that we figured out is there. So line BD is congruent to line DB. This is shared side. And the third thing is this whole thing right here. And this is kind of a weird situation because they tell us that it's an angle bisector, but your teacher, for example, or like what you need to show is that you know that that makes those two angles congruent to each other. So you need a third bubble up here. So your proof for these two angles being the same can't be this. This cannot be your reasoning for it. You have to have another bubble to show this. And it'll make more sense in a second once I write it all out. So right here you can say that line BD is an angle bisector, and that's given to us. And we can conclude from that so like this is a reason, and we can devise from that reason that angle ABD is congruent to angle CBD. And this is really, really important when you're doing, when you're not just saying like, oh, angle C, you're saying it's B, but there's two different angles, and you have to, and you have like 3 letters in a row. The third letter has to be the angle that you're referencing. So this is just for clarity reasons, because if you said angle B is congruent to angle B, that doesn't make much sense, because there's like 2 angles where the point B is, like that emerge from that. So you have angle ABD and CBD. It would be incorrect to put, DAB, because that would mean that you're talking about this angle right here, but you're not. So that's just something to be really mindful of. And our reasoning for this is the definition of a bisector. because as explained before, the definition of a bisector is that it makes those two angles congruent to each other. So that's our reasoning for that. So now that we have that, we can go on to our next proof. So from this, we can determine that triangle ABD is congruent to triangle CBD. And now, but how do we know that? Well, we have it here, but we still need to put a reason here. So we have one angle, we have a side, and we have another angle. So that would be ASA congruency. And that's our reason for that. And then, since we know that congruent triangles have congruent parts, that angle A is subsequently congruent to angle C. And that is how you get from all the way down to this conclusion. And what's really important is when you have something that's above these triangle, or above like a circle, it's something that you have to like mentally process, as in this case at least, we're given that this, that line BD is an angle bisector, but we didn't conclude that, like, this explicitly does not tell us that these two angles are equal. We had to conclude that for ourselves. So you have to show like how you came to those conclusions, and that's the whole point of a flowchart, is to like process how you're coming to these conclusions, because you can easily look at this and be like, oh yeah, those two triangles are equal, but you have to show that you know that. And as silly as it may seem, it's important for proofs later on. So you have to make sure that you say that, okay, this was given to me, and this is how I came to that conclusion, because you said this is a bisector, and I know that the definition of a bisector is that these two angles are going to be equal to each other. So that's how I know that angle ABD is congruent to angle CBD. So that's one of the most important parts of doing this kind of thing. And then again, just making sure that like you're writing out your angles properly and you're understanding those angles that are given to you properly. So BDA, you're looking at D, and it's just for clarity so you know that BDA, you know that it's going to be that angle, this side right here, and it's not this side, obviously, because it didn't say C anywhere in there. So it's like determining if you had like a V, A, B, C. You could say angle B, but if there was something else over here and there was like another point D, you'd have to say A, B, C, or C, B, A, because otherwise, like, could it be this angle? I guess if you said angle B, no one knows which one you're talking about. So that's something that you really have to be mindful of. So now you know how to make a flowchart proof for two shapes to see if they're congruent or if some of their parts are congruent.